All right, so let's go ahead and write down all the formulas. So sum and difference. Okay, so the sum and difference formulas for cosine are the first ones. Yeah, so we'll do the cosine first, and then we'll do sine. So number one, cosine alpha plus theta is equal to cosine alpha cosine beta. Sine alpha times sine beta. All right. Number two, cosine alpha minus beta is going to be equal to the same deal, except we put a plus in the middle. So cosine alpha cosine beta plus sine alpha sine beta. Okay. Number three, the sine difference formulas and sum. So sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Number four, sine alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. Okay. So we need all these guys for this homework here. 8.5. There's a couple that use the shift. I guess you can go ahead and write them. I don't know if it's going to come up much, but they're derived from this these guys up top. Cosine pi over 2 minus theta, some angle, will be shifted into sine theta. And same thing for sine. If you have pi over 2 minus theta, it turns into cosine. Maybe that'll come up, would be useful when we establish an identity. Oh, there's also the tangent, I almost forgot. 7. The sum and difference of tangent. Okay. Tangent alpha plus beta is equal to tangent alpha beta, yeah, alpha plus tangent beta over 1 minus tangent alpha tangent beta. Number 8, tangent alpha minus beta will be the same deal, just swap the signs. So tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. There we go. Almost done. Yeah, I think that is all of them. All this formula we will need for 8.5. Double check. Yes. Okay. Now ready? Let's do some examples. You guess someone have a question? No. Okay. All right, so the first few examples in your homework are pretty basic. Let's start with something like this. Using the sum or difference formula, find an exact value. So part A, let's say cosine 75 degrees, right? Cosine 75 is not on the circle, but we can easily break it into a sum of things that are on the circle, right? So this is simply what? Cosine 30 plus, well, actually, yeah, that's the actual word, plus 45. Make this a little smaller, might need space. Okay, so I chose 30 and 45 because those are on the circle, right? So I will be using equation number 1. So the formula would be cosine 30 cosine 45 minus sine 30 times sine 45. They're all degrees, right? So these are all easy values that we can find on our circle. So this will become cosine 30. What is that? It's going to be square root 3 over 2, right? Square root 45 would be times square root 2 over 2 minus sine of 30, 1/2 times sine 45. So now you have an exact answer once you multiply these guys. So root 3 times root 2, that is root 6 over 2 times 2 minus 1/2 times root 2 over 2, that'll be root 2 over 4. And that does not get any prettier than this. Is there any questions on part A here? Okay. All right then. Let's do another one, but this time we'll use radians. Part B. So again, this is an exact value. And we did not use a calculator because the calculator would give you a decimal. So we use this guy. All right. Okay, so cosine, let's see, pi over 12. So when it's in radians, it's a little harder unless you're really comfortable with your fractions. From experience, I can see that this will be simply cosine of 3 pi over 12 minus 2 pi over 12, which is cosine of pi over 4 minus pi over 6, which are on the circle, right? But if you can't see that and you're like, how the hell did I get there? Or where did this come from? Well, you can always convert this if this bothers you, right? You could say, you know what? I don't want to deal with that. Do it up here in some scratch area. I'm going to convert this, right, back to degrees so I don't have to deal with fractions as much. So that will become 180 degrees over 12, which would be what? Let's use our calculator. Yeah, this is really 15 degrees. Okay, so I could actually say, you know what, I don't want to do, I don't like this, I could be doing this. I'm like, okay, since it's pretty small, then I'll have to do a difference, right, to help us out here. So I could do cosine, let's see, 45 degrees minus 30 degrees. That is equal to 15, right? And then we could apply the formula here instead of there. Of course, it will be the same. All right. So the difference formula is right here, number 2. Okay. Let's use number 2. Cosine 45 degrees times cosine 30 degrees plus sine 45 degrees times sine 30 degrees, which will be root 2 over 2 times cosine 1, that'll be root 3 over 2 plus sine 45 root 2 over 2 times sine 30, which is a half. That will give us square root 6 minus plus square root 2 over 4. So similar to the last question, except it's plus. So they were both cosine, so anyway. Is there any questions on the basic idea for the sum and difference and how it could be helpful? Okay, let's do a different question.
Profesor, The answer is square root of 6.
Yeah, square root 6 plus square root
And
2 divided
did you
by
get
4.
that from multiplying 2 by 2?
This is square root 2 times square root 3.
Okay, 3. Okay.
Yeah, this is a
Thank
3
you.
right there. Yeah, I ran out of space. I'm sorry. I should write that bigger. Here. Okay. Square root 2 over 2 times 1 square root 3 over 2 plus square root 2 over 2 times 1/2. Okay. Let's do another example, a different kind of example. So if sine alpha is equal to 4/5, and let's say alpha is between pi over 2 and pi. And sine beta is equal to -2 over root 5, where beta is between here, pi and 3 pi over 2. Find the following. So part A, it's kind of bright for me.
Is that a 17? Or is pi over 2 and greater than alpha? Or
Pi over 2 less than alpha, less
less
than
than alpha?
pi. Right. Okay. Part A is cosine alpha. Part B is cosine beta. Part C is cosine alpha plus beta. And D is sine alpha plus beta. My alpha look like Jesus fish, so whatever. Okay. There we go. So notice how all these questions are going to require us to find the cosine parts, because these formulas need cosine alpha, sine alpha, cosine beta, sine beta. And all we have right now is sine alpha and sine beta. So we're going to have to solve, basically these represent two different triangles, okay? So we're going to find those guys. So before we start on anything, let's find all the missing pieces. And remember, the quadrants will guide us to where the, it will guide us into knowing if cosine is negative or sine is negative, etc. Okay, so using the alpha, here's alpha. They define it as 4/5. So 4 over 5, right? Opposite over adjacent. Pi over 2, or alpha is between pi over 2 and pi. So what quadrant is that?
Mm,
2.
Yeah, it's going to be quadrant 2, right?
mhm.
So that means cosine is negative. So when we find it, using Pythagorean theorem, we will have a negative cosine. This is a 3, 4, 5 triangle. So it's going to be 3 when you do the work. Okay, so sine alpha was given to us. That will be 4/5. Now we have cosine alpha. By definition, it is the adjacent over hypotenuse, so 3/5. Let me write that better. Okay. All right, now we need another triangle, right? For the other guys. So for beta, we have beta in which quadrant?
Mm. 1.
3.
This is
Oh.
the from pi to 3 pi over 2.
3.
Yeah, it's gonna be the third one. Let me pull up the circle so you can see it. So you know how to read it, right? Because it could be weird. So it says from pi to 3 pi over 2. So we're in here, third quadrant. And the first one said from pi over 2 to pi. That's why we know it's quadrant 2, right? Okay. Also, we said cosine was negative, so negative in quadrant 2. In quadrant 3, they are both negative, correct? Okay, so -2 opposite over adjacent. We need that adjacent side. So I don't know why I put a minus there. That's fine, it doesn't matter. So a squared plus b squared is equal to c squared. So I'm gonna do it, just some scratch work over here. So b will equal 5 minus 4, which is 1, right? This squared is 5, this squared is 4, subtract it over 1. Okay. Technically, it'll be -1 when you do the square root stuff, but we already know that sine and cosine are both negative, so we don't have to worry about this. But here we go. So sine beta is -2 over root 5, which is the same as -root 5. Oops. Make this a little bigger. And we'll put alpha first. For no reason. Okay. Alpha. So that will be, I don't know why I put beta. What am I talking about? It's supposed to be beta. Okay. Sine beta was right. -2 over root 5. If you rationalize, that'll be -2 root 5 over 5, which we don't really have to, just doing it just in case. Now, cosine beta is equal to adjacent over hypotenuse, which is a -1 over root 5, which is negative root 5 over 5. So I can't write very well in that corner. Okay, so I have all the pieces that I need. Then I can start using the formula, right? So part A, we kind of already wrote it. Cosine alpha is equal to -3/5, right? Part B, cosine beta is equal to, either one is fine, negative root 5 over 5. I don't know why I wrote that all this stuff. I think someday in my life I'll write a 5 correctly, maybe. Okay. 5. Okay. And then we have the harder part, C. So cosine alpha plus beta, the formula says that's going to be cosine cosine minus sine sine. You do not have to memorize these. That should be, yeah. Okay. Plus. Yeah, if it's plus, cosine is opposite. Plus is minus. Okay. All right, so just plug everything in and we're good. So this will be cosine alpha, so -3 over 5 times cosine beta, negative root 5 over 5 minus sine alpha, which is 4/5, times sine beta, which is, I believe I wrote it this way, -2 root 5 over 5. Okay. So then just calculate this and we're done, right? -3 times negative that, whatever. It's going to be positive. 3 times root 5, right? 5 times 5. Negative, negative. That'll be a plus at the end. So that will be 8 root 5 over 25. Yeah, there we go. 4 times 2, root 5 stays. They're both over 5. 5 times 5. These are the same radicals, so you can actually add these. 3 of these plus 8 of those is 11 of those guys. 11 root 25, or over 25. Okay. So any questions on how you set this up and how you do A, B, or C? Okay. So D will be similar. D was just a sine, right? Sine alpha plus beta. Formula says that is sine cosine cosine sine. Sine cosine cosine sine. Double check. Sine cosine cosine sine. Yep. Okay. So now plug it all in and finish this guy off. So this will be 4/5 times cosine beta, negative root 5 over 5, plus cosine alpha, which is -3 over 5, times times sine alpha cosine alpha. Double check here. Yeah. Oh, hold up. Something's off here. Alpha beta. It should end in beta, not another alpha. That doesn't make sense. This is wrong. Beta. So sine beta will be -2 root 5 over 5. -4 root 5 over 25 plus 6 root 5 over 25. So -4 of those plus 6 of those is 2. Okay. That's pretty much all you're going to see in 8.5 is that first example, something similar to that, or something similar to these A, B, C, D parts. Guys have any questions on these examples?
I'm sorry, did you say for our next exam?
I'm sorry?
Did you say for our next exam or the exam we took?
No, I said, do you have any questions on these examples?
Oh, I thought you said exam. I was like,
No, not yet.
okay.
I think
No.
we review for exam 2 next week.
Okay. Sounds
Okay, let's move on to 8.6.
so for our class, you said that you were gonna finish grading the work for our exam.
Yeah,
I
it should
think.
be done pretty soon.
Oh, okay. Just maybe.
Probably by either tonight or tomorrow. Okay, let's see here. All right, let's write down all the formulas for 8.6, and then we'll take a short break here. I don't know what 8.6 is called. Double angle and half angle formulas. Okay, let's do the double first. All right, so sine 2 theta, formula is 2 sine theta cosine theta. Number 2, double angle for cosine has 3 forms. It's going to be cosine squared theta minus sine squared theta.
What's that first one say?
Sine 2 theta is equal to 2 sine cosine.
Are they multiplied?
Yes. So 2 sine theta times cosine theta.
Thank you.
Okay, the next one is cosine 2 theta, so another form. is 1 minus 2 sine squared theta. 4, another cosine 2 theta is equal to 2 cosine squared minus 1. Okay. Number 5, double angle for tangent. Tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. Okay. Number 6, these are also called the power reducing, these next two. So if you have a squared sign and you don't want to deal with it, you can reduce it and change it into a one powered function, but you double the angle of this cosine. Cosine is the same, just with a plus. It's kind of neat. Like if you have a fourth power, you can just do this over and over again until you no longer have powers. So these guys are sometimes called power reducing formulas. They're very useful in calculus too. Okay. Number 8. Tangent squared is equal to 1 minus cosine 2 theta over 1 plus cosine 2 theta. Those are all the double angles. Technically, this is also a power reducing, but it's really just dividing these two, right? But whatever. Those are all the double. Let's do the half angle. All right, first one, sine squared of alpha over 2 is equal to 1 minus cosine theta, or sorry, alpha, over 2. Number 2, cosine squared alpha over 2 is equal to 1 plus cosine alpha over 2. Number 3, tangent squared alpha over 2 is equal to just the quotient of these two. 1 minus cosine alpha over 1 plus cosine alpha. Okay. Number 4, sine alpha over 2 is equal to plus or minus 1 minus cosine alpha over 2. I think I can put them going downward. That's fine. Number 5, cosine alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha over 2. 6, the tangent. Is equal to plus or minus 1 minus cosine alpha over 1 plus cosine alpha. 7. Another way to write tangent alpha over 2 is 1 minus cosine alpha over sine alpha, which is equal to sine alpha over 1 plus cosine alpha. There we go. So tangent has 3 forms, I guess. Okay. Let's take a short break. 6:55. Come back around 7:10, and we'll start 8.6. Okay. All right, so example 1, we'll do something similar like the other example in multiple parts. So if sine theta is equal to 7/8 and theta is between pi over 2, find the following. Okay, part A. Find the double angle of sine, or in other words, sine 2 theta. So technically you could use the sum of angles and change it to sine plus sine, but that wouldn't be any fun. That would be a lot more work. So use the double angle formulas. Change it to 2 sine theta cosine theta. So now all we have to find is cosine because we have sine. Now we are in quadrant 0 to pi halves. That's quadrant 1, right? So both sine and cosine should be positive. So let's just find our Pythagorean theorem stuff. Theta. Sine is equal to 7 over 8. Do our Pythagorean, this would be root 15. So we can fill in the blanks. This would be 2 times sine. Sine will be opposites over hypotenuse, adjacent over hypotenuse. Okay. This is just multiply together and we're done, right? 2 times 7 is 14 times root 15 over 8 times 8. That reduces to this. Okay. So not too bad, right? Part B. The same deal here. Cosine of 2 theta. We use one of the double angle formulas. Remember, cosine 2 theta has 3 different forms. But notice how we have sine to begin with. So we should use the one that has sine in it. That way we don't have to technically use cosine. But we have it, it doesn't matter, but let's pretend we didn't know what cosine was, so I'll use this guy. So the answer will be 1 minus 2 times sine squared, which is 7/8 squared. Okay. So it'll become 1 minus, that'll be 2 times 49 over 64, which is really 1 minus 49 over 32, which is a negative, right? 1 minus 49 32s. Yeah. Let's see. Negative 17 32s. Anyway. So if you have sine, I recommend using the one they give you. Part C. Do you have any questions on A or B?
No questions.
All right. All right, so the next one's a little more challenging. If you remember the formulas for half angle, there is a plus or minus on there, right? 1 minus cosine theta for the sine over 2. So now they decide, okay, they'll use the plus or the minus. And that is determined by the location of theta over 2, not theta. Okay, so we know that theta is where?
Quadrant 1.
Quadrant 1, right? So if I divide everywhere by 2, then I'll get 0 is between theta over 2 and pi over 4, right? You see what I did? Divide this by 2, this by 2, that by 2. So that's what I did here. All right. So is theta over 2 still in quadrant 1?
Yes.
Yes, right? And let me pull up the thing in case you don't see that. So originally we had 0 to pi halves, right? So I cut it in half, so now I'm going to 0 to pi fourths. So I'm still in the positive. Because of that, I will choose the positive sign here. Okay, so I'm going to use a plus. Or just don't write the sign at all. 1 minus cosine theta over 2. We found cosine to be, right, root 15 over 8. So these aren't going to look very pretty, but whatever. 1 minus root 15 over 8 divided by 2, which will be 8 minus root 15 over 16, which reduces to 8 minus root 16. Outside the root, this becomes a 4. Anyway, the key part is, do you understand why I picked the plus, how I figured this out, and getting to here? After that, after this step, it's just fractions and stuff, but this setup here is the most important. Does that make sense? Okay. Let's move on to a different example. Given that cosine alpha theta is equal to negative root 5 over 7. And we have theta in this quadrant here. That's a pi. Pi to the pi, there's quadrant 2. So cosine is negative there, which is true, right? Sine is negative there. Okay, now let's go ahead and find the half angle because it's probably going to come up. Pi over 4 less than theta over 2 less than pi over 2. Which quadrant is this?
One.
1.
Yeah, that's 1, right? So we went from quadrant 2 to 1. So now when I use that, if the half angle formula comes up, I'll use the positive. Okay. All right. Part A, find the following. Forgot to say. Part A is sine of 2 theta, which we know is a formula of 2 sine cosine. We do not have sine, so we should probably find it. Here is theta. Here is cosine hypotenuse. Doing a Pythagorean theorem, this would be root 44. Let me double check. Sorry. I don't know why I put 144. That would be 49. Square that would be 5. Yeah, that's right. So 44, which is really 2 root 11. Okay. And this part will be positive because sine is positive here. Okay, so then sine 2 sine cosine will become 2 times sine, opposite over hypotenuse. I'm going to use 2 root 11 over 7. Cosine will be this guy here, right? Okay. So actually, one moment, guys. Let's get back to this question. All right, so found sine and cosine by definition, right? So opposite hypotenuse, 2 root 11 over opposite, negative root 5 over 7. So this will be 2 times 2 is 4. Root 11 times 5. So this is the only time you can multiply the insides or affect the insides is with multiplication. So this will be root 55 over 49. There we go. All right, next one. Part B. Let's go ahead and move to a harder one. Let's do the half angle. Theta over 2. So the formula we did before was plus or minus 1 minus cosine theta over 2. But we need to decide. We said we are no longer in quadrant 2, so we should not use that. Quadrant 1, they're both positive, so I'm going to stick with this one. So this will become 1 minus cosine theta over 2. Plug in cosine, and that will become 1 minus cosine adjacent, so that'll be minus a minus root 5 over 7 over 7.
Is it over 2, not 7?
Oh yeah, sorry about that. Thank you. 2. Okay, so then we will get us a common denominator, so this will be 1 minus root 5. And then eventually you end up with 14 down here. Okay. And that is as pretty as it's going to get. Yeah, let's go ahead and do cosine for fun, right? Cosine theta over 2. That will be same formula except that there's a plus in here. Plus or minus 1 plus cosine theta over 2. Cosine is root 5 over 7. So 1 minus, oh, I forgot something, didn't I? This is a minus. So this should be a plus here. Root 5 over 7 over 2. It'll be the same thing, except minus. Okay. Do you have any questions on double or half angle formulas? Okay. Next one will be the last one for 8.6. Yeah. This one's a little annoying, but oh well. Continued. All right. So here we'll solve an equation. Solve the equation on 0, where theta is between 0 and 2 pi. So it'll be sine 6 theta minus sine 3 theta equals to 0. So right now, it's a little difficult to solve. Although, this is technically what? Sine of 2 times 3 theta, right? Because I have a double of this guy. So 2 times 3 is 6. So I can technically use the double angle, right, to get this guy. So sine 2 theta, our theta is 3 theta. So pretend this is like your one big theta. Okay. So I'm going to apply the formula to this here, giving us 2 times sine 3 theta cosine 3 theta. Okay. Now I can factor sine 3 theta, technically. Sine 3 theta factor from both of them would get me 2 cosine minus 1. Okay. All right, so remember, when you have two things equal to a product of two factors equal to 0, you can use a zero factor property and set them each separately to 0, right? This would be what? Cosine 3 theta equal to 1/2. Sadly, these are triple angles, which means we'll probably have quite a few. Yeah, okay. Well, here we go. So regular sine is 0 at 0 and pi. So I know that the solution, right? How do I phrase it? Yeah, this would be better. If we just treat it as one angle, 0 plus 2k pi would be where any sine function is equal to 0. But since it's not just theta, I have to divide it out, which would give us theta equal to 0 plus 2k pi thirds. Now the other location, 3 theta, is equal to pi plus 2k pi. Theta would be equal to pi thirds plus 2k pi thirds. All right. There's my two sets. Let's do the same deal over here. When is cosine equal to 1/2? Well, that happens when the angle is equal to pi thirds plus 2k pi. And that also happens when it's equal to 5 pi thirds plus 2k pi. All right. Divide by 3 on the first one, that would give us the first set of pi over 9 plus 2k. Make some space, you can barely see that. Theta will be pi over 9 plus 2k pi thirds. The other one we said was 3 theta equal to 5 pi thirds. theta would become 5 pi ninths plus 2k pi thirds. All right. So now let's create our set. So these right here are the infinite sets. But since we are looking at all the answers between 0 and 2 pi, then I will use these two sets to create the solution set, which is finite in this case. Okay, so remember we said that if it's 3 theta or triple angle, then there should be k equal to 0, 1, 2 sets of solutions for each one of these. So each one will have 3 sets. So we're going to have 12 answers. So here we go, right? So let k equal 0. So theta 1 would be equal to this guy, right? That would be 0. Now putting 0 here, theta 2 would be pi over 3. Now putting 0 there, theta 3 would be pi ninths. Theta 4 would be, putting 0 here, would be 5 pi ninths. Okay, so there's my first set. Now let's let k equal 1. Okay. So for the first one, k equal 1 would be 0 plus 2 pi thirds. So just basically 2 pi thirds. Theta 6, theta 6. Sorry, lost my train of thought. It would be pi thirds plus 2 pi thirds. That would be 3 pi thirds, which is pi. Okay, theta 7. Putting 1 there, it would be pi ninths plus 2 pi thirds. Pi ninths plus 2 pi thirds, which is 7 pi ninths. Theta 8. Putting in a 1 in here, it would be 5 pi ninths plus 2 pi thirds. 5 pi ninths plus 2 pi thirds is equal to 3 times 3, 6 plus 5, 11 pi ninths. All right. Now let's do k equal to 2. So go back to this guy. So let k be 2, that will be 4 pi thirds plus 0. So the first one, theta 9 is 4 pi thirds. Theta 10 will be pi thirds plus 4 pi thirds, which is a 5 pi thirds. Theta 11, almost done, be pi ninths plus 2, k is 2, so 4 pi thirds, which will be 12 plus 1, 13 pi ninths. Last guy here, 5 pi ninths plus 4 pi thirds will be 17 pi ninths. All right, so the set of all thetas will be 0, pi ninths, 5 pi ninths, 2 pi thirds, 7 pi ninths, 11 pi ninths, 4 pi thirds, 13 pi ninths, 17 pi ninths, pi over 3, pi, 5 pi thirds. Should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that question was not a nice one. But you see when you have, as we mentioned before, if you have a double or triple angle, it becomes tough. But if you have 2 sets of triple, then yeah, it's gonna be crappy. Anyway, is there any steps that don't make sense, or any questions on this guy? All right, we'll stop 8.6 here and let you process some of that. And we'll start 8.7 next time. I guess I'll let you go. If you have some questions, you're welcome to stay for a bit, and if not, you're welcome to head out.
Thank you. Have a good night.
Have a good night.
Thank you.
Hi, sir. I have a question.
Yeah, what's up?
I know this is like ancient history, but on the homework for 7.8, the
Mhm.
last like 5 problems on it were like pretty lengthy word problems that I feel like was beyond the scope of what we learned in class.
Okay, I'll check it out. And you email me so don't forget the details.
Yeah, of course. Thank you.
Yeah, I'll check it out. Maybe I can delete some of those guys.
Thank you. Have a good night.
Have a good night.